Very good afternoon to all. So I welcome our expert Dr. C.C. Reddy from IIT Ropar once again today for his third lecture on the third day. So very good afternoon and welcome, sir. Please start your lecture.
Thank you, Dr. Balvinder Raj, and thank you, Professor Piyush Verma. So I'll start my presentation. This is on overhead covered conductors, surface voltage and surface current simulation on for safety of living beings contacting the surface of an overhead insulated conductor. So this is actually a part of our one of our journal paper, invited journal paper in SIGRE journal, SIGRE India journal. So contributed by my students Ajit Jhan Thomas, Ayyappan, and of course Uma Shankar is from industry, and myself is also an author of this. This is simulation on safety of human beings contacting the surface of an overhead insulated conductor. I will briefly introduce the background and then types of overhead conductors, covered conductors, and then explain the details of this paper. So background, what are the problems with bare overhead conductors? So let us see, for example, this bare overhead conductor here going through a tree. The tree is just beneath this one. Maybe when the line is laid, this tree was not there, but over a period of time this has grown and then became like this. For some branches are cut, but regular maintenance is required if overhead line is a bare conductor. Bare conductor means there is no cover or insulating cover on the conductor. So when a tree touches it, obviously it will conduct to the ground, and then there may be problems of fault, short circuit, or interruption may happen, and it may be dangerous to human beings also, or any living beings also. Like we will see. And transmission lines are often, the places where birds flock together like this, and they may even electrocuted on the line itself, resulting in a fault or resulting in the loss of life of birds. So this is another problem. So actually these birds find it a very good environment for them to sit on these lines, because they can clearly see the prey also, and they can while going away over a long distance, the birds seasonally move like that. So before going like that, they may sit on these lines because they are free of any obstacles. Like unlike if a tree, if they sit on a tree, there may be some obstacles. So they find it very comfortable to sit on this, but they do not know with the way that it is dangerous. So this is another thing, and then you can see here some tree branches falling on the line. So this may also result in failure or breakdown or temporary interruptions of lines. So as for the safety of human beings or animals or living beings, so this is how a tree, when it is touching a line, so there will be a conducting path like this to the ground. So what will be the potential at this touch at this point? Just think over what will be the potential. So the potential is in fact almost zero potential here. Zero potential drop means almost line voltage will be there here. Almost line voltage, because the drop along the tree is negligible. So almost line voltage will be there. So at the bottom or at the tree. So if one touching here and then having legs on the ground, definitely large current will flow through the body, and then it may cause, it may become fatal to living beings. Now you can see for around 60 kilovolts, so the safe distance is 10 meters roughly. So after 10 meters, here the potential becomes 0. So what causes actually, what is dangerous to human being? Actually, it's not absolute potential, but potential different between two touching points. For example, if a human being is standing one leg here and another leg here, like this, so then what will happen? There will be potential difference between this leg and this leg. So obviously current will flow like this. So this path. So the potential difference actually causes failure, fatal. So here, if a man is touching this tree at this point and his legs are there on the ground, then there is a potential difference, and then obviously it will cause huge current to flow, and then it may be fatal to him. So like this, a tree touching a transmission line is dangerous to living beings also. So apart from this, animals, directly climb the trees and then may fall on transmission line. You can see cheetah. This is in India. Hindustan Times has reported this. Elephant also died due to a low-lying, transmission line due to sag. So this is another problem, and some animals will climb here. You can see here how the breakdown of the breakdown or flash out through the body of the living being has taken place. So it is this way, many number of animals are dying in here due to these kind of events. So electrocution of animals, and then not only this electrocution happens unless people go and clear it physically. So the fault will be there continuously. So this causes, interruption. Actually, major distribution, level, and then medium voltage level. Major faults are due to these reasons only. And then the problem is to identify the location and then reaching the location and then clearing the fault. All this will take place 3-4 hours. It's a big problem. You might have observed the local towns, how many times the interruption takes place. It's all due to these reasons only. A tree branch may be falling on this, and then or an animal, a bird sitting on that, and then some electrocution or some wire, falling on the ground. All these things are happening, and the quality of the power supply in our towns, etc., is seriously affected by these kind of events. So this is due to bare overhead conductors, which are not covered by any. Here you can see how the electrocution happens. As long as a bird sits on one, line, electrocution will not happen. But the moment it tries to fly, and then the moment it spreads its, wings, then the wings may touch both the wires and electrocution through the bird. So this is how it is causing serious loss of life also, and serious disturbances to the power system also. So this is the background. You can see even natural calamities. This is a transmission line, and on this, these trees have fallen. This is Pacific snowstorm that takes place in Western countries. So apart from this, even in our country also, during rain or thunderstorms, several trees will fall on the lines, and they may cause the failure of power or breakdown of power system. So these problems do arise due to these bare overhead conductors, uncovered, not covered overhead conductors will cause such problems. So what is the solution? So there are solutions, several solutions. Of course, these have to be, fully implemented. They are just gaining momentum. Some developed countries have already gone for them, but still in developing countries, due to cost reasons, these are yet to be incorporated or yet to be installed. So what are the solutions? The solutions involve covered conductors and spacer cables and aerial cables like that. So this is this system is called spacer cable system, in which you can see a messenger wire here and then 3 cables, and they are separated by a spacer arrangement like this, hook-like shape, and then with spacers, etc. So these are solutions for that. But what are the problems, research problems, and then misconceptions existing among the industry, and then on these? So let us see what are the benefits of covered conductors. Using insulated covered conductor instead of bare overhead conductor is actually gaining momentum recently due to several advantages, such as improving power system reliability, because majority of the faults, majority of the disturbances are due to these only, bare overhead conductors, and then some tree falling on them, and then even birds sitting there and then getting electrocuted, or lightning happening on the conductors. So these are the causes. They will be definitely minimized by using, covered conductor. And without a major change in infrastructure, enhanced to a higher voltage level. It can be enhanced to a higher voltage level, because the clearances, etc., required for the covered conductor are less than the bare overhead conductor. Therefore, what will happen? The voltage level can be enhanced. So with the same infrastructure, whatever we are using, instead of bare conductor, if we use a covered conductor, the voltage level can be increased. So the power transmission capability automatically increases. So this way, it reduces capital cost also. A lot of savings can be, achieved in this manner. And third one is environmental aspects. Forest fire. You may have heard recently in Australia, forest fires did happen. So these bare overhead conductors have more potential to cause these fires. Animal electrocution is mostly in African countries. These things will happen. Of course, in India also they are happening. You have seen the photographs. And disturbance due to tree falling are mitigated. So these can be avoided using the covered conductors. Now, other benefits you can see: low life cycle cost compared to bare conductor, and then reducing the maintenance cost of tree trimming. See, if bare over, you have to check along the transmission line, the distribution or transmission line, and then cut the trees. Always this trimming, is an additional maintenance cost. So this can be reduced. And then reducing clearance between phases can manage with direct contact between phases also. Sometimes you can even bundle the covered conductors of 3 phases also. It's not a problem. So environmental advantages. So these are the benefits of using the covered conductor. And major applications involve in even high temperature and UV conditions also. So these can be applied, and cold environments where right-of-way problem can be minimized. So right-of-way problem means, farmers not giving a lot of land and all. So the land required can be minimized because the clearance has become small. So reduced face-to-face clearance, covered conductors can be very useful in solving the right-of-way issues. So you can see here, this is in Sweden. The tree branches are lying on these conductors, but these are covered conductors. That is why there is no problem, without any problem, power supply. There is no interruption to power supply. Simply the tree branches are lying, and then power is continued to supply. This is taken in Sweden. reported in a conference. So this is these are the advantages. Now we see the basic types of covered conductors. Covered conductors means on conductor we will have some insulating cover. So you can see this is the basic type of single sheath covered conductor. Among all the covered conductors, it is cheapest actually. So simply one layer of insulation is kept on the conductor. This is conductor, and then this black one is insulation. So single layer, single sheath it is called, single sheath covered conductor. So it is Pirelli cable systems has produced this one. So and then this is three sheath, triple sheath or triple extrusion process is used to manufacture this one. So here this is a conductor. On that there is a inner semicon layer. So this is conducting layer, of course, but it is made up of plastic XLPE only, the plastic insulation only. So polymer insulation only. This is XLPE. So in order to smoothen the surface of this conductor, this additional XLPE layer with conducting layer is used, this black one. And above that, this insulating layer, this white one, is XLPE insulation. Just like cables, XLPE insulation is used. And above this one, this for weather protection. So this additional layer is used. This is the material actually tree retardant material it is called. So it is a special material which will not allow tracking on the surface of the insulation. So this is how it is three layer triple sheath covered conductor. So this is a little bit costlier, but it has additional advantages. And other than this, people have come up with spacer cable system. This already you have seen. So this is Hendrix company has produced this one. So the spacer cable system you can see here. 3 cables separated by spacers. 3 cables are of 3 phases, and then there is a messenger line wire above this system. So this is one system, but it is a bit costlier than this one. And the final one is actually, why don't we put a cable only? Why not? Why go for covered conductor or bare conductors? Just whatever underground cable, submarine cable, whatever is there, same type of construction we make for overhead line also. So simply the cable single, casing. In the single casing, we can have 3 cores of cables. You can see 3 phases, and then insulation is surrounding to all these conductors, which is packed in this manner. You can see several layers can be seen. Here also inner semiconducting layer is there, outer semiconducting layer is there. There is a screen and there is a sheath, and there is an armor surrounding this one. This is called universal overhead cable. Universal overhead cable. So it is Ericsson company has produced this one. So this is of course being universal has no problems at all, but it is costlier than all other types of conductors. So you can see these 4 options are available, of course, with slight modifications. Several types of cables are available in the market nowadays. So these are the basic types. Then here you can see the cost versus reliability. Reliability means supply power without any interruption. So how reliable? The more reliable means the more pure quality of power supply without any interruption. So you can see cost on this axis and then reliability on this axis. If this is the bare wire has low cost, but its reliability is very poor. And then reliability can be significantly achieved. For example, with aerial conductor, this is the reliability. Around 90% of the reliability is achieved by this covered conductor. So aerial cable is, this one, third one. This is the aerial cable. So, and spacer cable is this one. This is the spacer cable. So this is the cost comparison given by Jay Wareng. He has done a lot of survey of these things, and you can see the cost is not much actually, around 50% of the area, 40% of the area cable, but the reliability is around 90%, you can say roughly. So this how covered conductor is attractive for the industry to go for it. So again, there is another report from Japan, Kyushu Island, that from 1965 onwards and still 1984. So installation rate. This is the installation rate of covered conductor. So as it is increasing now, it is 1984 if you consider as 100%. So then accident per year is getting reduced. You can see. So accident per year means, even faults or interruptions, all these things are getting reduced. So this curve explains, this figure explains how important it to go for a covered conductor. So, but what are the differences between a cable and a covered conductor? Covered conductor has insulation surrounding it. So I'll draw, this is central conductor here, and then surrounded by insulation. Of course, other layers you can ignore for the time being. So you can consider having only one layer. So this is the insulation. So a central conductor is covered by insulation. But insulation outer layer, what is the potential? So that is, we have to think about it. And then as for the cable, what is the cable? Cable is also having a central conductor, but after outer insulation, of course, I am ignoring the other small layers and all. So after outer insulation, there will be a small semiconducting layer on this, and this outer layer is at ground potential. It is grounded actually. So inner conductor is at high potential, and outer surface is at ground potential. This is cable. And this is covered conductor. Covered conductor. In this case, covered conductor, the outer potential, what is the potential? This is open surface. So this is, since this is open, you can consider this as forming a capacitance with ground. Suppose it is overhead conductor. So this is ground and it is above the ground. Then what will happen? So there will be a capacitance between this conductor and outside, and then capacitance to ground. So the voltage gets redistributed among these two. So since the capacitance of this is very small, capacitance of surface to ground is very small because large distance will be there. Roughly inversely proportional capacitance is inversely proportional to D or height. So this capacitance C earth, shall we say? C earth you can say. And this capacitance C covered conductor, if you say, CE is much less than CC, because CE is earth potential which is having large height, so that's why CE is less than CC. Then what will happen? Impedances, if capacitance is like this, then capacitive impedances are XE is ulta, it is greater than XC, because the 1 by j omega C is the impedance, right? It's the capacitive reactance or impedance. So XE will be greater than XC. So in that case, what will happen? Where the potential will be more, the potential drop will be more in the air. So the potential drop in the conductor will be very small. So if the potential drop in the conductor is very small, what will happen? The surface voltage, if it is V, then the covered conductor voltage, if it is V, just in practice actually, just only 5% of voltage drop will be there in the insulation. So around 95% of the voltage will be there on the surface of this covered conductor. So you can see, imagine, so since it is not grounded, when is it? It is on the overhead conductor. So 95% of the voltage will be there on the surface, even if it is covered conductor. So then people might think, then what is the advantage? Because conductor and even covered conductor are having almost same potential when it is on the line. So if someone touches the, will it be dangerous? So that question might come, and then that in fact is confusing the, developed countries where people are hesitating to go for this one for some reason. So in order to clarify, we have done some investigations. Of course, there are reports, but we have made some investigations and simulations and have shown what is the effect. So even if 90%, 95% of the voltage will be there on the surface of the covered conductor, but will it be dangerous or not? How far it is dangerous? That needs to be simulated and seen. So in case of cable, of course, it is the outer potential is 0 and therefore no problem at all. So the other two cases where, spacer cables and then, other aerial cable case. So if the outer layer is at ground potential, then there is no problem at all. So, but in case of covered conductor like this, without any conducting surface at ground potential, then we need to show that there is no danger if something falls on that. So that has been done using simulation. So this is the electrical equivalent circuit of, complete equivalent circuit of the covered conductor. Here you can see the surface of the covered conductor, and we have modeled it using distributed capacitances and inductances and resistances. So here the central one is the conductor. So conductor is modeled with RL like this, you can see. And then the covered conductor is modeled with capacitances. Basically it is capacitive impedance. So like this. And then of course we have incorporated some surface resistance here. Under steady state, this surface resistance role may be negligible. And if there is no current in the conductor, you can neglect the RL components also. You can simply assume it as a two capacitors in series. And these capacitors represent capacitance to ground actually. So this is the model adopted for, analyzing the effect actually. So with this model, we have simulated in PSpice. So just these are the specifications that are used by us in our simulation. Conductor diameter is 33.42 and insulation thickness 9.55 mm. Overall diameter 52 mm and then relative permittivity 3.9. Silicon rubber actually we have used as insulation material, and cable capacitance per unit length per meter actually is 480 picofarads per meter. So with our simulation, we have simulated voltages for different line voltages. We have simulated what is the conductor surface voltage. Surface voltage means above the insulating cover. So on the surface of the insulating cover. You can see here for 10 kilovolts, the voltage on the surface is 9.69. 20 kilovolts, 19.39. So 30 kilovolts, surface voltage is 29. 40 kilovolts, 38.79. So almost very few percentage drop in the insulation. So the conductor voltage, this one, and the surface voltage, this one, are having very little difference. So then this confuses the industry or vendors. Then what is the effect when someone touches the surface? So that is also simulated here. So this is a human body, and human bodies, of course, the resistance of the human body depends on individuals also. Typically 1000 ohms is the lowest impedance that can be assumed, and then maximum can be 10,000 ohms also. So here this is the conductor, and then there is a cable, overhead conductor capacitance, that is insulated conductor capacitance, and then human being is touching and he has certain resistance in his body, and then ground. So this is incorporated here in this circuit using this equivalent actually. So you can see there is a switch and there is a resistor RH, and there is a switch, and then the switch suddenly closes. And then what will happen to the current through this resistance as well as the voltage on the touching location. So this is what is investigated now. So you can see here at this instant around 20 milliseconds, the switch is closed. So when the switch is closed, you can see this is the current through that 1 kilo ohm, means the current through the human being, you can assume. So you can see the maximum is just touching 4 milliamperes. 4 milliamperes. And then after that, immediately, this is transient period. After some transient incident, immediately the transient comes to almost zero. So you can see again the voltage is also, voltage drop across that 1 kilo ohm is around 4 volts, very small. So just before touching it is in kilovolts, but after touching it becomes simply 4 volts. And at the same time the current you can see also is a very small current. So how this happens, just think over, I will explain also that also. Now the current and voltage under contact condition, these simulated results are here. We have changed the human body resistance from 500 ohms to 100 kilo ohms. So with the different resistor values, you can see the current has changed very little. Current is almost same, but the voltage has changed from 1 volt in the transient condition to 354 volts. It has increased, but you can see the steady state current is very small in micro amperes, and the steady state current didn't change, and the transient current peak also didn't change. It is in milliamperes, around 3.4 milliamperes. And then here the steady state current is around 452 microamperes, and the voltage is around 2 volts to around 354 volts. It has changed with changing the resistance. So can you think of why for different resistors the current remained almost same, but at the same time voltage changed a little bit? So just you think of about it. And then what are the effects actually? Electrical current, effect of electrical current on human body. That's also generally known, this one. Below 1 milliamperes, generally it is not perceptible. Battery current, you cannot even, sense it that, something is passing, the current is passing. And around 1 milliampere, faint tingle starts, and then around 5 milliamperes, slight shock. So, and then 6 milliamperes to 30 milliamperes, a little painful shock, but loss of muscular control may happen here. And 50 milliamperes to 150 milliamperes, extreme pain and, death is possible. So this is the harmful effects of the current. And you can see we are in the less than this range actually, even in this range. of that is transient current, and very microseconds it will last. After that, immediately it will jump into microseconds. You can see 0.4 amperes, below this current. So even not even perceptible. So surface, of our conductor, although it is having high voltage when it is not touched, the moment if someone is touching it, assuming the body resistance, etc., is around this in this range, then the currents show, the simulations show very negligible current and negligible impact. Of course, experimentally also we are trying to find it out. So this is what the simulation result tells. So more or less not dangerous for any living being if it touches the overhead conductor line, which is insulated or which is covered. If it is not covered, it is fatal, of course. If it is covered also, the currents are, the simulated currents show very little magnitude, and compared to these conditions, they show not so severe. So this is the result. And then, of course, before concluding, I must tell you why this is happening. Why when the insulation resistance, when the resistance is increasing also, there is no change in the current. So actually it is again the, I had to take some space somewhere. Yeah, here I will draw. So this is like this actually. Here you have, capacitance, of course, and then actually this has resistance also, very huge resistance. That's why normally we ignore the resistance. Very huge resistance, and you are connecting in series with that very small resistance. Maybe 1000 ohms is nothing. Even 100 kilo ohms is nothing. This resistance is in, mega ohms to giga ohm level. Mega ohms to giga ohms level. Now, when you are connecting a resistor of 1 kilo ohm or 100 kilo ohm, the drop across this resistor becomes negligible, almost negligible. So actually, total impedance, this is V, right? It is the circuit, equivalent circuit becomes like this. Of course, this AC you can assume. Equivalent circuit, huge impedance, and then small impedance. Right? Now, irrespective, if this is in giga ohms, say, irrespective of the value, whatever you connect here, so the effective impedance will be seen as this giga ohms only. That is why the current in this is not getting affected much by changing of this small resistance, the human body resistance or whatever it is. Now, but why the voltage drop is changing? Because current is almost constant, current into whatever resistance you are using. So that linearly increases the voltage at this node. So this is how the phenomena is explained easily. So, but what it indicates for us is the perceptible currents are not flowing in the simulation when a human body or equivalent resistance touches the surface of the conductor. So this needed to be clarified. So that's why we have performed this simulation, and we are still doing the experiments, of course. And then this is the conclusion of this work. The proposed network model can also be used for validation of surface voltage measurements that we are doing, of course. And evaluation studies, role of surface resistance, thickness of the insulation, and then design considerations can also be obtained using the equivalent circuit. And what my main conclusion is, covered conductor, touch current is seen to be below 1 milliampere in steady state, therefore generally not perceptible in steady state. So this is what is the conclusion of the work. And then research areas. So in this, lot of scope for this covered conductor is new technology. It is, of course, developed countries have already gone. lot of research is possible. Cracking is a phenomena on the surface that can be investigated. And when burn down happens, what are the consequences that can also be investigated, and what is the effect of lightning if it strikes on the covered conductor, and excessive tracking over a period of time, what it will cause, and vibration, fatigue, etc. And trees, if they continuously lie on a covered conductor, what is the impact? So that also can be investigated. And detection of a downed conductor. This is another thing, when covered conductor falls on the earth, then the entire voltage will be across the covered conductor insulation only. So it will not cause any fault, earth fault, unless the broken conductor is touching the ground. So if it is not touching the ground, then there will be no fault. So how to sense this one? This is a difficulty actually. Of course, there are methods people are coming up with imbalance currents, for detection of this kind of fault. Means, a covered conductor falling on the ground or, downed significantly. So which need to be identified by some fault currents, etc. Since actual fault, earth fault is not taking place because the conductor is not touching the ground. If conductor is touching the ground, then obviously this fault will happen. But if it is not touching the ground, you cannot detect it using this earth fault, relay and all. But obviously, when the conductor is falling on the ground, and if it is having an exposed conducting part, then obviously since this is at high voltage, and then when there is a ground here, obviously there should be flashover, and then definitely it must be causing the fault. But in case if it does not, cause flashover and all, so even in that case also, imbalance currents may be detected. People are doing research on it, and the topic is open also. Anyone can do the research also. So this sensing the current imbalance between the three conductors, because one of the conductor has fallen, other two conductors are lying, same on the transmission line. Therefore, there must be some imbalance created. So by this falling conductor, so that can that be sensed? So that must reflect in the currents in the branches. So it must be found. Some signals we may get, and then based on that, we may sense the fault location and all. So this is also an important research area. And since this is being a transmission line, a different transmission line, so the load flow studies, etc., are also be relooked into in the light of covered conductors. So this is scope for new research areas. It opens up several aspects of research here. So with this, I thank you. This is my presentation for this lecture. Thank you. Now it is open for questions.